Chapter 6, Section 5, Part 2, Linear Inequalities. This is just a review from yesterday. Okay, to graph this, we're going to start just like we did when we graphed at the beginning of the chapter. We're going to graph our y-intercept first, put a point at -1, and then our slope is 2, so we go up 2 over 1. And then our next decision is whether we need a solid line or a dotted line. And because I don't have an equal to bar on our inequality, I'm going to use a dotted line. Okay, and then I have to decide where I'm going to shade. So I am going to choose an order or a point. I'm going to use 0, 0 because it's the easiest. So I'm going to put 0 is less than 2 times 0 minus 1. 0 is less than 0 minus 1, which gives me 0 is less than -1. Because 0 is not less than -1, I don't shade there. I have to shade on the opposite side. That means anything in this shaded region would be a solution for my linear inequality, but nothing on the dotted line. Okay, we're going to try this in word problems. For a party, you can spend no more than, that's a key word right there, $12 on candy. Jolly Ranchers cost $2 a pound and Sweet Tarts cost $4 a pound. What are 3 possible combinations of Jolly Ranchers and Sweet Tarts? Okay, so I'm going to define my variables. I'm going to say that Jolly Ranchers are X, Sweet Tarts are Y, and I'm going to write myself an inequality in standard form. So I know that 2x, because it's $2 per pound, plus 4y has to be less than or equal to, because I can spend no more than $12. Okay, now there's a couple ways that I can do this. The best way, or the quickest way, is that I could use intercepts, x and y intercepts. Remember that when I'm trying to find an x-intercept, I get rid of the y. To get x alone, I would divide by 2. So my x-intercept is going to be 6, 0. My y-intercept, I do the opposite. I would pretend that the x isn't there, and I would have to divide by 4 to get the y by itself, which would leave me with the y-intercept of 0, 3. Okay. Then I'm just going to graph those 2 points over 6 up 0, put a dot, and over 0 up 3, put a dot. And because it has the equal to bar, I'm going to make a solid line to connect the two. Okay, I'm going to try again 0, 0 to see if that is a solution. So 2 times 0 plus 4 times 0 is less than or equal to 12. Well, all of that is 0, which, yes, is less than or equal to 12. So I'm going to shade everything down here below the line. Okay, by doing that, I should be able to choose 3 possible combinations of Jolly Ranchers and Sweet Tarts. Anything that's in that shaded region would be a solution. Okay, so I'm going to say right here, what if I bought 0 Jolly Ranchers, but 2 Sweet Tarts? Okay, so over 0 up 2. That is one possibility. If I bought 0, let's see. Oh, that's up here, sorry. This one is 2, 0. Okay, what if I bought 2 Jolly Ranchers, 0 Sweet Tarts? Or maybe right here, buy 2 of each. All of those are within my less than or equal to $12. Okay, so same idea. Suppose you can spend no more than $20 for hot dogs and hamburgers for a picnic. Hot dogs are $5 per package and hamburgers are $8 per package. What are 3 possible combinations of hamburgers and hot dogs that you could buy? Okay, so we're going to say that hot dogs are going to be my x, hamburgers are going to be my y. So when I write my equation in standard form, I will have 5x plus 8y has to be less than or equal to the $20 that I have to spend. Okay, so if I find my x and y intercepts, I'm going to cover up the y. Yeah, let's do this. Okay, so if I cover up the y, divide by 5, I'm going to find my x-intercept is 4, 0. If I cover up my x's so I can find my y-intercept, 20 divided by 8 gives me 5/2. Okay, then I'm going to graph those 2 points, which would take me over 4, up 0, and over 0, up 5/2, which is 2.5. Okay, it does have an equal to bar, so we're going to have a solid line. And I'm going to try this 0, 0 again. If I plug in a 0, I will end up with 0 is less than or equal to 20, which it is. So that means I get to shade all of this underneath the line. Okay, and everything on the line would also work since it's a solid line. So I could pick, we could all have different answers, but I could say that I'm going to buy 2 packages of hot dogs, 0 hamburgers. I could buy, right here, I could go 0 hot dogs, probably not 2.5. Let's go with 2 packages of hamburgers. I could also go over here and do 4 packages of hot dogs, but 0 hamburgers. All possibilities. Okay, last 2 things. They want you to look at this graph and choose which inequality actually represents it. First thing I want you to look at is the fact that this is a solid line. So that means we need to have an equal to bar. Okay, so that means this one is not an option. Okay, then we're going to look at our y-intercept, which happens to be +1, but so do all of these. Okay, then we're going to look at our slope. Looks like we are going up 2 over 1, which eliminates letter B. The last thing that we're looking at is whether everything that we shaded, which is what our y represents, is above or below the line. Okay, if it's below the line, it's a less than. If it's above the line, it's a greater than. Okay, this yellow area is what is shaded, and because that is underneath or below the line, we need a y is less than or equal to, so this is our answer right here. Okay, and last but not least, they're going to give you a graph and you actually have to write it. So the first thing I'm going to do is just write the equation of the line without our inequality symbol. So it should look like a y equals mx plus b equation, only this will be an inequality. Okay, so first thing I need is a y-intercept, which happens to be -1. Then I need a slope. Looks like I'm going up 1 over 2. Okay, so right there is my equation, and because it is shaded below the line, it will be a less than. Y is less than 1/2 x minus 1. And I left it without the equal to bar because it's a dotted line. All right, that wraps up 6.5 on linear inequalities, so you should be able to complete page 393, 8 through 20 evens, 30 through 34, and the lesson quiz.